It's just math. So in this problem, we are going to find all x such that the first derivative of y is less than 0, where y is 2x cubed minus 9x squared plus 24 ln x. So first of all, of course, we're going to take the derivative of y. So y prime will be 6x squared minus 18x plus 24 over x. So this 6, negative 18 and 24 has a common factor, which is 6. So 6 x squared minus 3x plus 4 over x. Then we can rewrite this x squared minus 3x plus 4x. We can multiply by, so basically we're going to make all the denominators to be equal to x. So it's going to be x cubed minus 3x squared plus 4 over x. Okay. So basically now we need to factor this x cubed minus 3x squared plus 4, but usually since it is a polynomial of third degree, we are not get used to factoring a polynomial of third degree, but we can try to plug in several values of x, hoping that we find at least one root of this polynomial. So without further ado, after I checked several x, I found out that when x equal 2, so for x equal 2, this x cubed gonna be 2 cubed minus 3 2 squared plus 4. What is this equal to? 8 minus 12 plus 4, which is exactly equal to 0. So what this tells us about? This tells us that x minus 2 is a factor of x cubed minus 3x squared plus 4. So because of that, then we can divide this x cubed minus 3x squared plus 4 by x minus 2 by using long division of polynomial. So let's do it. Well, you can use by synthetic division or just an usual polynomial division. We're gonna do the normal one. We divide this by x minus 2. So it's gonna be x squared, x cubed minus 2x squared, and we subtract. So we have minus x squared plus 4. So we get minus x minus x is minus x squared plus 2x. We subtract again. It's gonna be 4 minus 2x. So that's going to be negative 2. So this indicates that this guy can be rewrite as x minus 2 times x squared minus x minus 2. Okay, so let's continue. So we continue this. So that is equal to 6. We factor the numerator as x minus 2 times x squared minus x minus 2 over x. Now let us look at the quantity. This one. We hope that we can factor this as well. Can we? If we put a negative 2 plus 1, that works. So this is actually 6 x minus 2 x minus 2 x plus 1. So that's the factorization. So we just need to solve when this expression less or equal to 0. So we make a real line, and we put on this real line all x such that the expression is equal to 0 or undefined. So in particular, when x is equal to 0, it is undefined. So it is here 0 is undefined. When x equal negative 1, it is equal to 0. When x equal to 2, it is also equal to 0. So in fact, this one can be combined as x minus 2 squared. So let's scratch one of these. And put it squared there. Okay. Now we're just testing all values in between, here, 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 here. Let's say we plug in 3. That's going to be positive. Right. So each of this guy, that guy, and that guy are positive. How about to the left of 2? So actually this one is always non-negative, right? Okay, so when x is less than 2, this is positive. This is also positive, so this is also still positive. Between negative 1 and 0, it's going to be negative. And here going to be positive. Okay. So if the problem is asking about y prime of x greater or equal to 0, I think the right problem is greater or equal. So if and only if. So the point where the value is exactly 0 is part of the solution. So that's part of the solution. And the 2 is also part of the solution, but not when x equal to 0. So the solution is negative infinity till negative 1, including negative 1, and then union 0 to 2, no, 0 to 2, and then 2 to all the way to infinity. So it's going to be from 0 to infinity. So that's the answer. The answer is the curve, or y prime is, I think it's we're looking for when it is negative. Okay, so let's just put it here. Y prime of x is less or equal to 0 when, of course, the rest of this then, when x is between negative 1, including negative 1 and 0, but 0 is not part of it. Okay, so that's all. So that's the video. Thank you for watching. See you again in the next video. Bye. Oh no, I'm crying.